All right, second to last video. We're almost there. Trust me, your teacher's happy about it too. This is a weekend. It's beautiful outside. I'm in here making videos for. That's what I get paid for. All right, let's go. So here's a couple example problems. We're getting more into let's just solve some problems. Now these, I like these for tests. I think they're pretty mellow. Students do really well with them. So you get two pieces of information. Maybe you'll get two trig functions, then it asks you to go get the others. And by the others, there's 6 trig functions. They're sine, cosine, tangent, cosecant, secant, and cotangent, along with sine and cosine. So anytime it gives you 2 and it's asking for the others, that's what it means. Now, this problem's so mellow. I don't even care what quadrant we're in. We're in quadrant 2, by the way. That's where sine is positive and cosine is negative. That's quadrant 2. But this is so mellow because we know that tangent is sine over cosine. And once you learn a little trick with it, my goodness, you could just state the answer. Negative 1 over root 15. Do you see they have the same denominators? So I'm going to replace sine with 1 over 4. I'm going to replace cosine with root 15 over 4, negative, of course. Now, this is the way I'm going to hope you do it. This is the way that it's going to work out every time. Sine and cosine have the same denominator. It's just going to cancel out, and you're going to get negative 1 over root 15. They always have the same denominator, so they always cancel out. But why? So I'm going to go old school. Division. You remember this? 1/4 divided by negative root 15 over 4. Just going old school for a second. You know that stuff? I think we learned this, 4th grade, 5th grade, something like that, but we probably haven't used it much lately. But maybe you remember, you're like, oh yeah, when I get these divisions of fractions, I flip it over to its reciprocal and multiply. So you flip it over and you multiply. The 4's cancel out. And we get 1 over negative root 15. The negative doesn't matter. It could be out front. It could be on the 1. It could be on the root 15. It doesn't make any freaking difference. So there we go. We found out that tangent is equal to negative 1 over root 15. Purposely putting the negatives on different spots because it does not matter where the negative is. It's one of the tricks I like to use. Once we're here, everything else comes for free. It all comes for free. Let's go to cosecant next. Cosecant is the reciprocal of sine. So we're just going to flip over sine. It's 4 over 1, or just 4. I'm not a high school teacher, so I don't require that you write the 1 below it. Now we want to find out what secant is. It's the reciprocal of cosine. I am not rationalizing the denominator. I'm just going to leave it. And then let's get cotangent. It's the reciprocal of tangent. You get negative root 15 over 1. There's our values. This is not a bad game. This is just solidifying what we know. Now we're going to see another one, but it's going to require a little bit more work. We're going to get 2 pieces of information. Tangent's a third, and we're in quadrant 3. Find the rest. Find the other 5. Oh, there are 2 different ways of doing this. You could do the book method by using this. Oops. Tangent squared plus 1 is equal to secant squared. I don't like that method. Then you can get secant squared, you can get secant, and then that'll give you cosine, and then you can go and do some other work, but that, I don't know. I just much prefer to do this. I'd rather make a triangle. Actually, let's change this. I'm going to make this negative. I'm going to put you in quadrant 2. I won't start hitting you with the tricks quite yet. And go, okay, let's draw. It says quadrant 2. Let's just draw a triangle in quadrant 2. So anytime we're going to draw a triangle, it's like you're making a bow tie. If you want to make a triangle in quadrant 2, it goes here. You want to make a triangle in quadrant 3, it goes like this. You want to make a triangle in quadrant 4, it goes like that. You want to make a triangle in quadrant 1, it goes like that. It makes a little bow tie, huh? Do not attach to the y-axis. Now what this does is we're just using the Pythagorean theorem. We're doing it visually too, so we don't make any silly-ass mistakes. So this is stating that's the opposite. That's the adjacent. So I'm going to claim that the opposite is -1 and the adjacent's +3. I'm now saying X X is 3. Y is -1. Do you see anything wrong with that? This height, that's the positive Y direction. This is the negative X direction. But you're like, no, but dude, the negative was on the 1. Who gives a shit where the negative? You can put it down there. It's still negative. So you get 1 and -3. Now let's go find the hypotenuse. This is a right triangle. It's a right triangle. And we call it C, and C is always positive. So we get 1 squared plus -3 squared. If you're not watching, I'm not writing the negative on the 3 when I do this, because we're always going to square and it's always going to be positive. So we get 1 plus 9 is equal to C squared. 10 is equal to C squared. Therefore, C is equal to the square root of 10. You don't need a plus or a minus with a hypotenuse. Hypotenuse is always positive. Till chapter 4. Okay. So now we have root 10. Now let's solve the gosh darn triangle from the reference angle. It's going to give you the rest. We look at it and we go, sine of our angle is the opposite over the hypotenuse. 1 over root 10. Cosine is going to be the adjacent over the hypotenuse. -3 over root 10. There's no reason to really look at anything anymore. We already knew tangent was -1 over 3, so that got us cotangent, right? We just flipped it over. We didn't even need to make a frickin' triangle. Shoot, you want to maximize your points, and you're like, I have no frickin' clue what to do. You're like, well, I can at least know this. I don't know how to make a triangle, but shit, I know to flip over tangent. And then we go get the rest. Now, I'm not even looking at the triangle any longer. Cosecant goes with sine. So we're going to get root 10 over 1. Secant goes with cosine. So we're just going to flip over cosine. Get root 10 over -3. There's all the trig functions. I prefer that game. I don't think you want to do tangent squared plus 1 is equal to secant squared. But maybe you do. I don't know. I don't know you. Maybe you're like, I love fractions. Fractions are my favorite. You know what I mean? Having to do it this way. We're popping in our -1/3. And then we get a 1/9 plus 1 is equal to secant squared. We put it all together. And I know I'm going fast because I don't like this method. It's equal to secant squared. Now we hit it with a square root on both sides. You get a root 10 over 3 is equal to secant of theta. Is it? Is it? No, it's plus or minus. We'd have to look back, figure out which freaking quadrant we're in, and recognize we're in the second quadrant where cosine's negative, which means secant's negative. And now we have secant. Then you'd be able to get cosine by flipping it over. What's going to be your method? Then we could use sine squared plus cosine squared is equal to 1 to go get sine, which will go get your cosecant. This seems like too much work. I'd rather just make a gosh darn triangle and then solve it. Solving triangles? A squared plus b squared equals c squared? Knowing SOHCAHTOA? Knowing which quadrants they're negative and positive in? I think that's going to cause a lot less issues and a lot less fractions. Well, all the answers have fractions. Did we have to do any fraction work? No. So you choose your method, figure out what works best for you, and use that. I'm not going to pigeonhole you into like, solve it this way. No, just solve it. Just solve it. All right. Beautiful. We'll have a game about evens and odds, and then that'll be it. We will be done with this section. Hallelujah. See you in the next.